5-8, Graphing Absolute Value Functions. Describe how each graph is related to the graph of y is equal to the absolute value of x. So when we create a table with 0, 1, and -1 as x's, we put in our 0 and we get 0 back. We put in 1, we get 1 back. We put in -1, we get 1 back. It always comes out being positive. So how does this graph get moved? So we look here and we see our origin is right here, and 1, 2, 3. This graph is translated down 3. So you need to write the word translated and down 3 to tell what happened in the graph. Graph each function by translating y is equal to the absolute value of x. So we know this graph is right at the origin. So this one says +3. So if x is 0, you can see y is equal to a +3. So I'm going to go up to 3, put my origin there. If I put in 1, the absolute value of 1 is 1. 1 plus 3 is 4. So 1, 2, 3, 4. So I know the graph's going to go in that direction, but I want to see what's going to happen on the other side. When I put in a -1, we get an absolute value of 1. 1 plus 3 is 4 again. So at a -1, we end up at a +4. Write an equation for each translation of y is equal to the absolute value of x. So here, 2 units down. So I went down 2. So y is equal to the absolute value of x, and I went down 2. So the next section, graph each function by translating y is equal to the absolute value of x. So when we are inside, something different is going to happen. So what we do is we pick the opposite of whatever this number is. So I'm going to put in a -6. -6 plus 6 is 0. So 1, 2, 3, 4, 5, 6. So at -6, 0 is my first point. So let's see what happens on this side. So at -5. -5 plus 6 is 1. The absolute value of 1 is 1. So I'm going to go up 1. So I'm going to go on the other side. -7. -7 plus 6 is -1. The absolute value of -1 is 1. So again, we end up with our V shape. So the absolute value keeps pushing for the V shape. But we can see our vertex moved to -6. When we have a +6 here, we end up at -6 to be on the x-axis. Back side of our paper on number 14, write an equation for the translation of y is equal to the absolute value of x. Now we're going left. We went left with 6 on the last problem, and we were adding 6. So we're going to add 7 because we want to go to the left. And that was being added to x, and that was inside the absolute value. Number 17, at the right is a graph of y is equal to -x. So if you look at it, y is equal to the negative absolute value of x. Look what happened. The negative flipped it upside down. But it's still a v, but it's upside down. So the negative outside the absolute value had the power to do that. So here we need to graph. So we do our table. And remember, we want the opposite of this one, so I'm going to put in -2. So -2 is 0. So I'm going to go out here to -2, 0, and there's my vertex. So I'm going to see what happened at -1. So if I put in -1 plus 2, I get 1. But when it comes out of that absolute value, I have a negative there. So I get -1 for an answer. So it flipped upside down. So let's see what's going on this side. So at 1, 2, 3, -3 plus 2 is -1. The absolute value of that is just 1, but this negative makes it -1. And that's how you graph, and that's what the graph looks like when you have a negative out in front of the absolute value.